Now in this video we will see different laws like commutative laws, distributive laws, associative laws, idempotent, identities, De Morgan's law. So one by one we will see different laws as to what set of operations obey those laws. For example, commutative laws, we will see that intersection, union, symmetric difference, they obey commutative laws. But set difference does not obey commutative laws. Similarly, intersection, union, and symmetric difference, they obey associative laws, but set difference does not. So we will look into what are these laws first. Means what is a commutative law? Commutative law is basically if you exchange or if you switch the operands, the left operand to be the right operand and right operand to be the left operand, even then the result is same given the operation. Let's say any operation is op is any operation, then there is a left operand op1 and there is a right operand op2. This op is said to be commutative if op1 op2 is equal to op2 op1. Okay. Now let's look into the intersection. B intersection A or A intersection B. From the Venn diagram, it is this region only. It's the same thing. Whether you do B intersection A or you do A intersection B, these are the elements that you are going to get in your set A intersection B or B intersection B. So A intersection B is equal to B intersection A, right? So what we get? We get that the intersection is commutative. Intersection operation is commutative. Now let's look at union. If you perform A union B, then you are getting all of these elements, or you perform B union A, then you are getting all of these elements only. Union operation is commutative. Union operation is commutative. Now look at symmetric difference. If you are doing A symmetric difference B, then these are the elements that you will get as a result of this operation. And the set B symmetric difference A also will have these elements only. So both sets are same. So the symmetric difference operation is commutative. So symmetric difference is commutative. Set difference. A minus B will give you this element, these elements. This is A minus B. A minus B. And B minus A will give you these elements. This is B minus A. So definitely these two sets are not same. A minus B and B minus A are not same. So set difference is not commutative. Set difference is not commutative. There's another law that involves three sets, which is associative law. You have three operands, and then you have this operation, any operation op. That is to be performed between two sets because op is a binary operation. This is one of the way you can do, right? This is one of the way you can perform the sequence of op operations when three operands are there. This is called left associative. This is left associative. Okay. The another possible way to perform this operation when you have three operands and a binary operator we say that the operation op, this op operation is associative if the results because of left associative and the result because of right associative are equal. Means that if the set that you get by series of ops because of the left associative way, or the result that you get by series of op operations because of the right associative way, if they are equal, that is said to be this op operation, it holds associative law. Intersection holds associative law, union holds associative law, set symmetric difference holds associative law, but set difference does not hold associative law. And if you look at this, these are the three sets A, B, and C. So just as this is the way to represent two arbitrary sets, this is the way to represent three arbitrary sets. Okay, three arbitrary sets in Venn diagram is represented using this figure. So now let's look into how the associative loss plays out in each of these set operations. On this side, I am doing A intersection B first, perform this, and with the result of it, perform intersection with C. In this side, A intersection B, first perform B intersection C, and then perform A intersection whatever the result is. So A intersection B is all of this area, right? All of this area is A intersection B. And then intersection C is only this part. In a similar way, when you do this, then B intersection C is all of this area, and A intersection B intersection C is just this part. Okay. So intersection operation is commutative and intersection operation is associative. So intersection operation is commutative and associative. Union operation. Left associative, A union B union C, and here right associative, A union B union C. Both ways it will give every element counted once. The result of all is all elements counted once. So left associative is equal to right associative. So union operation is commutative and associative.